Good evening, everyone. Welcome to the class. Today, I'm here to discuss the second part of chapter continuity and differentiability. So, before we start, let me know how all of you are doing. Okay, everyone is doing great. Yes. So, good evening, everyone. Let's just check 1 second before we begin whether I'm clearly audible or not and visible or not. Yes. So, audio looks good. Yes, audio looks good and video is also okay. Great. Akash is already here. Hi Akash, how are you? Good evening. How is your studies going on? Yes, I know, I understand you were all waiting for this class because we had discussed the basics of basically definition of continuity, definition of differentiability, and then again NCERT problems as well as different rules of differentiation in the previous class, right? Today I'm going to discuss the majority of the topics which is going to be on the logarithmic differentiation, implicit function, second order derivative, and the parametric form. Each of these categories has question coming in both boards and CET, right? So hi Akash, how are you? Okay guys, yes, so as I mentioned, whatever we're going to discuss today is very important for both boards as well as CET. Let's look at the structure before we move on. Okay, so the structure, if you remember, again, your latest blueprint as well as model paper has been out. Okay, as for your board has officially released your blueprint plus model question papers. Okay, we already made a video on that. You can go and check how to access those files, and very soon we'll be making we'll be helping you all solving the model question paper as well. We'll try our best, okay, but only if you require it right away. For example, since we have not done major of the portions, so we'll wait for a few months, at least 1 to 2 months. By then we'll be completing majority of the portions, and during your just right after your midterms we can start working on our model question paper also. Okay, but yes, both of them are available for you guys. Even in the question bank also is available. So your model question paper plus question bank, everything is released by your boards. Please go and check it out. So if you understand, if you go through the blueprint, you'll find it that in this chapter the board weightage is how much? The board and CET weightage, if you look at it, just number of questions, this is common among 17 marks and this is for 5 marks. Okay, and if you go and break down each of these questions that is coming, so you will find all these questions. One question on the logarithmic differentiation where you apply log on both sides and then solve it. Second, you're gonna find questions on implicit function as well. Okay, you're gonna find questions on second order derivative also for 5 marks. Same, you're gonna find them in the KCET problems as well. Okay, that's why this class over here, this class over here is very important for all of you. I've taken some unique questions that are little difficult on the side to solve in the class with all of you. Great. So this session, please, I hope you are all getting the PDFs and everything. Are you all getting the PDF assignment questions or not? Let me know, because we have been giving you all. Guys, all of you in the class, are you getting the PDF assignment questions or not? Because we are uploading all of it in our AIO, all in one platform. Okay, this is our learning platform. This is our learning platform. In this we upload everything, all our lectures, all the class notes. Okay, you get practice questions also, you get everything. Even you are having the ability to solve the doubts as well in that. So all is available in this platform. Please go and enroll if you have not enrolled yet. Yes, Akash is getting it. Okay, even assignment we are uploading it. If something is not updated, let us know, we can update that. Okay, so yes, all of this is available to all of you. Start learning. Okay, how to access it? If I have to give you a quick overview, for example, this video, if you check any video, if you check of ours, if you check this live also, in description you're gonna find what? Check over here, it's written as register for free batch. Okay, register for, check here, join the free second PUC course. If you click on that, so this is how it will open. Okay, this will be the basically the page which will open if you click on the free ACE KCET batch. Okay, and if you come and click on buy now, check here, it'll ask you for 0 rupees, there's no charge. You click on buy now. Since I have already logged in, with my information. You have to create your own login information. So this is my login, okay? I've created my login, but if you create your own, you can see this is how the learning platform will open. You'll have physics, biology, mathematics. If you want to go and check the lectures, you'll find everything over here. Class notes, quiz, there's InstaSolve, all is available, and whatever is not, you let us know, we're gonna upload and update all of it. Okay, so right now let's get back to the class. All right, sir, starting with log functions. So guys, all these tools are for your benefit and there's no charge behind it. Please make sure that you're all using it properly. If you miss out on this, means it's your disadvantage. Okay, yes. So why log function over here? Because just a quick revision of it. When I say revision, I will just talk about the type of function it is and basically the graph of the function, domain range. I'll talk about that as well. Okay, and some properties, because in logarithmic differentiation, when we learn the log differentiation, you'll see use of all these properties over here. Check. All these properties are useful over there. Okay, product rule is there. Then we have basically changing the base according to that. X with the base a can be written as e with the base a, x with the base e. Okay, then you have base change formula. Okay, this is the quotient rule, this is the power rule, where the n from the power comes as the coefficient, right? And again, if you have the same exponential function with the same base, the answer is always the value x itself. Don't worry, we'll talk about all of this in detail. Start from the log functions. What is the standard form? How do you write it? So write the log function like this: y equal to log of x with the base a, x with the base a. Okay, this is a monotonic function, means it has a unique way of unique nature. It is either only decreasing or only increasing. It all depends upon this value. This is called as the base value. The base value means log of x to the base a, right? So the base value, depending upon that, what will happen? Your the nature of the log will change, either only increasing or only decreasing, right, guys? So okay, if this is little bit new to you, you all must have seen exponential functions, right? So how do you write exponential functions, sir? Like this. If you have to write like this, if I write a power y equals to x, a power y equals to x, okay, and then I want to transform this into log, okay, then what happens? You write log over here of this value x. Whatever is the base, you write the base over here, and this y becomes free. How it is possible? Again, we'll look at it when we are learning the properties. Right, to understand this is the transformation between exponential function and log function. A power y equal to x is log of x with the base a equals to y. Transformation of exponential to logarithmic function. Okay, now let's look at the graphs. Okay, so before I draw your graphs for log function, we have two different graphs. Domain of log is always positive real number. It means log 0, log of negative number is never defined, and range is always all real numbers. Okay, graph will always pass through 0, 1. Okay, let's look at the graph. So if this is my function, this is the graph of the function log of x with the base a, but the condition is a must be always more than 1. Always more than 1. I said this base a in log is never equal to 0, never equal to 1, guys. Log base is never ever equal to 1. Who will tell me why? Can anybody tell me in the class why base of basically in this, whether in the case of exponential function or in the case of log function, this is never equal to 1? Why? Anyone? Akash, can you try? Can you try? This is because if you take basically this as 1, know what will happen? What will happen? It will become 1 power anything will be what? The same number 1 itself. There's no definition about it. Okay, so there will be no function about it. If you put this as 1, it will be always coming to the same value, right? So we always remember base of log is never 1. A is never 1. So whenever you have this value, whenever the value of base is more than 1, then what happens? Then the value of log, the graph of log looks like this, and this point is of course what? 1, 0. Okay, this goes all the way till minus infinity, and this goes all the way till plus infinity. And you can see over here, this is my domain 0 to infinity, where 0 is open. Domain is what? 0 open, infinity closed. Clear? This is done. Okay. Now, what is the other type? Other type, bacha, is this. Where the log is decreasing function. Can you see this is only increasing, this is strictly decreasing. Okay. This is the decreasing function. Okay. So over here, if you check over here, again the value will become same 1, 0. And this is the case when a is between 1 and 0. When the base a is between 0 and 1. And what is the function? Same, log of x with the base a. Again, domain and range will not change. Here also domain is 0 to infinity. Here also domain will be 0 to infinity only. And this will be what? -2 plus infinity. Clear? Basics is required. That's why I'm doing it over here. Next chapter is what? AOD. It will become very, very useful. Any doubts so far? Okay. We'll quickly cover it. And this is very, very important for this chapter's question. Remember, I wrote it over here as a power y equals to x. I wrote here a power y equals to x. Then I wrote here y equals to log of x power a. That's the transformation. I used this property actually. That's the property I used. You have a property as whenever you take a to the power log of x with the same base a. This is basically beta. This is basically what? Exponential function. A power something. Exponential function. What is the base? A. Log function base is what? Also a. So if you have log function and exponential function with the same base, answer is what? This value x. Whatever is over here, same will be the answer. Always. So when you are solving this question, when you are trying to solve this problem, okay, whenever you take this value, log of this value with the base a, and here also log of, excuse me, I can do it better. 1 second, guys. If I apply log on both sides, no, I'll have log a with the base a, log of a power y with the base a, and log of x with the base a. Check. Now this is the condition which is happening over here. Okay, here. Same property holds true here as well. Log with a with the base a is equal to 1. Log a with the base a is equals to 1. This all of you know, right? So check. This y will come out as coefficient. So if you write this step over here, I'll have y outside as coefficient, log a with the base a, and this will have log x with the base a. Check. This value is becoming what? Equal to 1. What do you have? Y into 1 equals to log with this. That's why we wrote the same result over here. Okay. So properties of log are very useful in your question solving. Okay. Correct. So any of you have doubt in any of the properties written over here on the screen right now? If you have, go ahead and ask me. They're very basic ones. You must have learned it earlier also. But if you have any doubt in any property, go ahead and ask me. There are a few more though. This is log of x with the base a. You have to basically, you can use this to change the base of log. Okay. So this is written as log x with the base log a. Log x by log a. Anybody can tell me what is the base in both the cases? In both the cases, base is exponential value, basically natural value e. If you look at this, this represents log of x with the base e upon log of a with the base e. Usually, we don't write this value log of x with the base e. Is simply, we write it as log x, or in some cases, we'll write this as ln x. Okay? Yes. This is basically the same result. Okay, log of m with the base n. You can write this as reciprocal form 1 upon log of n to the base m, just ulta. All right. Yeah. Now if you differentiate the log, this is the formula. The function will come in the denominator. Then you're going to differentiate this function using chain rule. Same you have for exponential functions as well. Okay. This is when the base is e, you have the value as it is. But if the base is a, you have to write log of a as well. Okay. Some basic formulas. Okay. I'm just revising the formulas of all these functions. Log ITF. Let's recall this part. ITF, how many are there? Total are 6. But majorly we use 3 to 4. Okay. So we use this one first in boards as well as CET. We have sine inverse derivative. Then we have cos inverse derivative. Okay. These two we write together because they look very similar. This is what? 1 upon 1 minus x square. What about this? Okay. Now tell me which other two look similar? Which other two look similar? Other two which look similar? Tan inverse and cot inverse. We'll write that. So again we'll have tan inverse derivative. I'll write it like this only. 1 plus x square. And fourth one, cot inverse x derivative. What is this going to be? Minus 1 upon 1 plus x square. Okay. Fifth one we have sec inverse of x derivative. That is going to be 1 upon x times of x square minus 1. And if you have the last one, rarely used but still it is important to know all of them, minus 1 upon, please check. Okay, all the 6 are given over here in the way you should remember. They are both same, just there's a difference of minus sign. Same goes over here also, plus and minus, here also plus and minus. Okay, correct. And cot inverse is same with the minus sign, right Akash? Great. So let us solve a question on ITF first. Let us solve a question on ITF. Tell me, what is my substitution? I would like to understand. I would like one help from all of you. That is, what is my substitution? In this question, I need to find derivative, right? I want help from all of you. What is my substitution? Any one of you? What should I take x value as? So remember, whenever you have 2x upon 1 plus x square, 1 minus x square upon 1 plus x square, or you have basically 2x upon 1 minus x square. Whenever you have these three forms, what all I said? Whenever you have 2x upon 1 plus x square, you have 1 minus x square upon 1 plus x square. Or if you have 2x upon 1 minus x square, in all the cases you take x as tan theta. X as tan theta. Okay, so apply. Can you quickly find the value of theta also from here? It will be useful for us. Tan inverse of x. If you take tan inverse on that side, it will become theta is tan inverse of x. That is my substitution. So look at this. I'm getting y equals to cos inverse of 2 tan theta upon 1 plus tan square theta. And right here you need to remember your formula of trigonometric functions. Which one is this? This is a double angle formula of sine in terms of tan. This becomes sine 2 theta. But sir, outside we have cos inverse, inside we have sine. What it means? It means I can transform this into cos and then only I can solve. Try this out now. Cos inverse. This will become cos of pi by 2 minus 2 theta. Cos 90 minus something is what? Sine of that angle. Okay. Now operate cos inverse of cos. You'll have the answer as pi by 2 minus 2 theta. Okay. Substitute the value that you got. Y equal to pi by 2 minus 2 times of tan inverse of x. This value in terms of theta. Differentiate. You get the answer as 0 minus 2 upon 1 plus x square. That's it. Done. Correct. That's right, Akash. All right. So this is clear. Anyone has doubt in this problem? So always remember these important forms. Okay. First one is 2x upon 1 plus x square, 1 minus x square upon 1 plus x square, and 2x upon 1 minus x square. Okay. This is the formula for sine 2 theta. This is for cos 2 theta. This is for tan 2 theta. Clear, right? Yeah. Next. Okay. Exponential function, same thing. What we had. So only thing is the domain of the log function will be range of the exponential function. The domain of this will be range of this. So in the logs, the domain was what? All positive numbers, 0 to infinity. That is over here. Right? And range was what? All real number. That is in the domain case. And the graphs are also Just mirror image, if you can see, this is the graph of exponential function. A power x when a is more than 1. When a is more than 1. It makes sense also. It makes sense. When you take this value as 0, 1, it will be passing through the point, right? This coordinate 0, 1. Check. Domain is from here to here all the way. All right. And if you go with the other graph that is there, that look like this. This is the case of, again, same a power x, but a value is between 0 and 1. That's true. If I take a value of the base less than 1, take example, a equals to 0.5, which is less than 1. Square it. What will happen if you square? Answer is 0.25. Cube. Answer is, what is it? 0.125. Power 4. Answer is 0.0625. Can you see? This is decreasing. If as you increase the power of a value, a base which is less than 1, the value overall is decreasing. That's why it is a decreasing function. When you take e power x, the base between 0 to 1. 0 to 1. Okay. Makes sense? All right. And as per the laws involved in exponential function, it is remain same as what you have learned in index, that you have learned in, I think, grade 8, grade 9, right? The product rule, quotient rule, sorry, product rule, quotient rule, power rule, all of that is same. Let's solve this question, which is on the chain rule application. Differentiate this sign first, then you have to tan inverse, then differentiate e power minus x, and then minus x. So if your y value is sine of tan inverse of e power minus x, differentiate, dy by dx should be, differentiate this sign first. It becomes cos, keeping this as it is, keeping this as it is. First derivative is done, right? Next will be one, differentiating sine as cos. Now we differentiate tan inverse. You'll have 1 upon whatever is inside, square of that. E power minus x the square. Okay. And then you're going to have what? Differentiate e power minus x. Remains as it is. Differentiate minus x, you'll have minus 1. Derivative of minus x is minus 1. Okay. Check. This I can write in the front, e power minus x with a minus sign, cos of tan inverse e power minus x upon. How many of you, even thought of writing this as positive? Whole square is there, sir. This is whole square. Becomes positive, right? Do you remember this formula? A power m power n. What is the result? A power m into n, right? So if you multiply 2 with minus x, the answer will be e power minus 2x. Usually our mind thinks in a way it's a whole square, so positive. And you'll have an option like that in the question and you'll lose marks over there. So please be careful. Properties are very important. This is the final answer. Chain rule question. Okay. Including, of course, exponential function derivative as well as log derivative. Yes. Correct. Don't worry. Very quickly, we're going to move on to your, actual question that we have here. This is the topic we're going to start today, right? But some basics revision before we start that. Cos by log x. Cos x by log x. Please give me answer for this. Cos x by log x. Give me answer for this. What property are you going to use over here, guys? Cos x upon log of x. What are we going to use over here? Of course, the quotient rule. Try dy by dx. Differentiate cos. You'll have minus sine x. Keep log as it is. Over here, what will happen? You'll have a minus sign. This time cos x as it is. Differentiate log. You'll have 1 by x divided by log x the whole square. Take minus sign common. Actually, you can take minus x common over here. So if you take LCM, right, you'll have x sine x log x plus cos x upon x divided by log x the whole square. Simplify this, you'll have the final answer. Check. You'll have the answer as minus x sin x log x plus cos x upon x log x the whole square. X log x the whole square. Yes. Come on. And we have provided you the links for our Pariksha Veda batch as well as AIO page. If you are somebody who's new, who have not started learning with us right now, you can join right away. Link is provided in the live chat as well. Okay. Yes. E power x log of sin 2x. E power x log of sin 2x. How do you solve this? This is the combination of chain rule as well as product rule, right? So I would like for you to answer this question. Options are given on the screen. Help me with it. Come on. Options on the screen. Which one looks correct? Tell me. Tell me. Which option is right? Because if you're here, you should know that very well. Just watching the lecture is not sufficient. Okay, you got to keep a pen and paper with you and solve the questions with me. Even you can solve half a step, like you can solve half a step means half of the total steps, or you can get the full answer without doing the steps. That's okay, but have some approach in, when you are in a class, try to learn something by, actually solving the problems. Just watching will not be sufficient. Okay, if watching was learning, then there's no problem in the world. Okay. Then things will be very, very easy. I can watch hours and hours of lecture and things are done. But actually what matters is, are you solving the questions together or not? That's what is important. So please help me with the answer for this question. Yes, come on guys, answer for the question number. Question on the screen. E power x log of sin 2x. You're gonna start with product rule. So when we differentiate, let's say this, I differentiate e power x, it will remain as it is. So you'll have e power x as it is, and this will be of course as it is. Okay, means one of the answer must have log sin 2x, and you can see all the four option has it. Okay. Next, if you continue, this time keep e power x as it is. Now differentiate log. You get sin 2x in denominator. Derivative of sine will be what? Cos 2x, the positive value only. Correct, right? Sin 2x derivative is cos 2x, that's positive only, into derivative of 2x, that will be 2. Check something is common or not. You'll get e power x is common. Over here you'll have log sin 2x plus 2. Cos by sin is cot 2x. So you're getting the answer as e power x. So there is no negative sign. So remove option C and option D. E power x 2 cot 2x and log sin 2x. Answer B is correct. Answer B is correct. Yes. Great. Now, logarithmic differentiation. This is a guaranteed question almost. This comes for 3 marks in your second PUC board. This question comes for 3 marks. If it is a simple question, then sometime they can give you for 2 marks also. Okay? Sometimes they can give you 2 marks if it is a very simple problem. When will we use this? When are we going to apply the logarithmic differentiation? There are 3 different forms. Whenever you see functions given as product, quotient or power, it means if it is function given as f into g, we will apply. If you have f by g, we will apply. And if you have f power g, we will apply. So 3 unique cases where the logarithmic differentiation is applicable and helps solving question faster. Okay. Great, sir. It makes sense. So for this question, let's say we'll try to solve. If I have a function y equal to f power g, let me understand this as simply y equal to f power g only. If you take log on both sides, it will become log y, the LHS side. This will be what? This part will be log of f power g. Check. It will be log of f power g. G can be taken in the coefficient. It will become g log f. That will become g log f. Continue then. So far I have, if you continue from here, you'll have log of y equal to g times of, what is it? Log f. Now differentiate this as a entire equation itself. Okay, so differentiate this log. You will have 1 by y dy by dx. Whenever you have a function of y, always write product of that derivative with dy by dx. Always remember that. How come? From the chain rule. Makes sense? Differentiate over here using product rule. Let's write over here as g dash log of f as it is plus g as it is, and this will become what? 1 by f, derivative of log, derivative of f will be f dash. Okay. Take this y on this side, you get the answer as y times of, if I write this, g dash log f plus g times of f dash upon f. And if you replace this y over here, what is y value? F power g. You'll get this is the answer. You get this as the answer. And if you remember this formula, this kind of question comes in your CET and can be solved much faster. Okay. If it is an objective question of your boards, also can be solved much faster if you remember the formula over here. Anyone has doubt regarding this approach? Anybody has doubt regarding this? Okay. Next. Sometime, we can also have the same approach with the help of exponential function. Try this out. This you all try out. The previous result that we got using taking log on both sides, you can get the same result using taking exponential function on both sides. What we're going to do? Basically, we'll have this as, so if I have y equal to y equal to f power g, right? Take e on both sides, you'll have e power f power g. E power f power, excuse me, sorry, not that. Writing this, sorry, this is part. Only the RHS side, right? This. We'll take this as e power log of f power g. This will become what? E power log f, and g comes as a coefficient. Yes, g comes as the coefficient. The product basically. Yes. Clear? So try this. Differentiate and get the result. For derivative, we'll get the same value as this. Now a question on this. This is your board's PYQ. This is a board style question. Usually comes for 3 marks. This question comes for 3 marks. Okay. How do you solve it? If you have y equals to, given as cos x times of cos 2x times of cos 3x. Cos x times of cos 2x times of cos 3x. Can you see what form is this? F into g into h. 3 function in product. Okay, sir. How are you going to solve it? Take log on both sides. You'll have log of cos x, cos 2x, cos 3x. Differentiate this value. Achha, before we differentiate, can we apply the condition of product law in the log? Log a, b, c is there. This becomes beta log of cos x plus log of cos 2x plus log of cos 3x. Right? Correct? Okay. Differentiate it. You'll have this answer as, differentiate now the entire equation. You'll have 1 by y. I just said, whenever you have a function in log, multiply a function in y, multiply with dy by dx, always. Check. What about this? Differentiating this, you'll be getting this cos over here, derivative of cos, that's minus sine. Plus. Check. You'll have cos over here, that'll become minus sine 2x times of 2. Chain rule will be applied, right? For log, you're gonna get 1 by cos. Cos will be minus sine and 2x will be 2. Continue. Plus, over here you'll have same result, cos 3x minus sine 3x times 3. Move y on this side. This will become tan, right? So if you have to write that, write this answer. Minus y times of, check this out. This will become minus y. This will be simply tan x. This will be what? 2 tan 2x, because sin 2x by cos 2x is tan 2x over here, plus 3 tan 3x. Plus 3 tan 3x. Right? Now, let us solve this question. Come on. Guys, give me the answer for this. Try once. Try solving once. If you have y equal to log of tan x by 2, find derivative. Anyone in the class? Anyone in the class? Anyone in the class? How do you solve? So half angle is there, so over here, and everywhere in the given options, it is x, right? It means I must be using somewhere half angle formula for sine cos. That's one clue. That is one clue. Okay. Other than that, we have to simply differentiate it. So to start, dy by dx equals derivative of log will be 1 by tan x by 2. That's for the log derivative. Differentiate tan now. You'll have secant square x by 2. This type of question can be asked in either, the easier questions of CET. Sometimes CET also asks some easy questions from each of the chapters, or can be asked in the board's MCQ side. Okay. This is a good question, by the way. This is very good problem for board's MCQ. Differentiate tan, you get secant square of x by 2. Differentiate x by 2 now, you'll have 1 by 2. So all three functions are differentiated. Rest is simplification. One thing is clear, sir. I will not have negative terms. Do I? I cannot see any negative term coming. Yeah. There is nothing like that. So let's write together. This is 2 is in denominator only. So write 2 over here. Tan is nothing but sine x by 2 upon cos x by 2. This value over here becomes sec square is cos square x by 2. Check. This cancels, right? So I get the answer as 1 by 2 sine x by 2, and here I have cos x by 2. This becomes 1 by 2 sine something into cos of the same angle. This becomes 1 by sine twice of the angle. This cancels. 1 by sine x. Option you all know. C. Option is C. Yes. Option is C. Next question. This is a KCET P by Q. This is a KCET P by Q. Solve it. Give a fair try. E power log of log x times of log 3x. You need to apply the properties of log, right? We have what? E power log of log x times of log 3x. That's the given function to us. This is the given function, guys. Yes. Okay. Whenever you have e and log together with the same base, right? What happens? They vanish because they are inverse of each other. Exponential function and log function are inverse of each other. What is left now? Just this part. So for this part, this first part over here, what is left? Only log x is left. How come? This property. E power log y is equals to just y. Same property I'm writing over here, where y is actually the log x in this case. Let me just take a different value. Let's say if I write here, e power log a will be simply a. Now we have log 3x, log x into log 3x. Correct? What will we do over here? What can we do over here? What can we do over here? Anybody? Anyone is thinking log of 3x square? That's wrong, right? Because it is log a into log b. Product rule is true for log a plus log b. You write it as log a into b, right? This is not going to be that condition, okay? But we can solve it using either apply log on both sides or simply product rule. So dy by dx equals to, check this out, you'll have the value as, differentiate this log, you'll have 1 by x log 3x, right? Or this time, differentiate this log 3x, you'll have 1 by 3x into 3. 1 by 3x into 3. Check. This 3 and this 3 also is cancelled. What do we have now? We have log 3x by x plus log x by x. Can you see now? This is very simple now. What I'm getting? Log 3x plus log x upon 3. So not 3, upon x. Anybody can tell me the option now? Anyone can tell me the option now? Come on, guys. If I'm telling you this is my derivative, which option is suitable option? What happened today? Come on. If I'm saying derivative is this, which is my suitable option? Can it be A? Can it be A? No, sir. It cannot be negative also. Clearly, my answer is what? You're going to take the product of these two. It will become 3x square. That's my option B. A very, very easy problem. A very easy problem. And I told you this is also a KCET question. Any problem? Now, this you all solve. This question, please all of you solve this. Because all of you can solve this question. What is given over here? Y equal to e power x. Y equals to e power x. Nothing different over here. Straightforward question of exponential function. Come on, try this out. Give me an answer. Which option is suitable for this? Which option is suitable for this? So we'll do what? Differentiate it. So we'll start from this function first. Okay, that'll remain as it is. If you take basically the function over here as u, derivative of this is what? Same, e power u. Then you have to differentiate this also, du by dx. This is done. We'll write e power x derivative again. You'll have the answer. Derivative of this is also same. So e power x, e power x. E power x times of e power x. As I mentioned, very simple problem. This kind of question can be asked for your board's MCQs. Okay. Yeah. Come on. Now we're going into parametric form. What happens when the questions are given in terms of different parameter? X is a function of t, y is a function of t. X and y is both a function of t. Then how do we find the derivative of dy by dx without actually eliminating the parameter? Okay. So what we do over here, we try to continue the differentiation of y with t. Basically, you go with dy by dx, dy by dt actually, that'll become g dash of t, and you do dx by dt, that'll become f dash of t, and then you take their ratio. That becomes your answer for dy by dx. Okay. What if same thing happens in the case of function? Okay, exact same thing. Instead of just a relation like this, we'll have a function, proper function. Let's say I can have sin x with tan inverse, cos x with log. If I ask you differentiate cos x with respect to log x, this is the condition for derivative of a function with another function. So you're gonna do what? Take this as y and this as, we can't do that, right? Let's do something else. T as cos x and q as log x. What are they asking? Differentiate p with respect to q. How do you solve it? Basically, dp by dx, the parameter x, and dq by dx. So both the function is in some other parameter. Differentiate that and put it in the ratio. If you differentiate dp by dx, you'll have the answer as minus sin x. And if you differentiate q with x, you'll have what? Answer as 1 by x. Log derivative is 1 by x, cos derivative is minus sin. Put the value over here. You get what? You get over here as simply minus sin x upon 1 by x. That becomes minus x sin x. That's the value of derivative of the function log cos x with log x. This is derivative of cos x with log x. Cos x with log x. Cos x with log x. Clear? Please have a look. Yeah. So even for the case of two different functions, we treat it in the same way. All right. So here we have again x given in terms of the parameter t. So basically x is a function of t and y is another function in t. What are they asking us? Find derivative dy by dx. So dy by dx will be what? Equals to dy by dt upon dx by dt. Dy by dt upon dx by dt. Try this. Anyone has an answer for this question? Anybody has an answer for this question? Final answer. Okay. A sin t. You'll have a cos t. A cos t. That's my first part. What about this? If you go dx by dt, differentiate this part. A is the constant, keep it as it is. Differentiate cos, that is going to be minus sin t. Now differentiate this. You have 1 by tan. Derivative of log is reciprocal. So log tan t by 2. Differentiate tan now. You'll have secant square t by 2 into 1 by 2. If you remember, right now we solved this derivative, log of tan 2. That came as 1 by sine. Remember, few questions back, we solved this. Where was this? Okay, here. Yeah, this one. Log of tan x by 2 was what? Cosec x, because it was 1 by sine. If I use the same condition over there also, can you understand that? Can you understand? This will also come the same. This part will be basically coming as, this part over here will be coming as 1 by sine t. Simplify and you'll get that. So basically this question, this step of this question will be a times of minus sine t plus 1 by sine t. This whole thing will become, when I take sec square over here, it will become cos square, right? Tan as sine by cos, there's a 2, cos and cos cancels. Okay, take LCM, minus sine square t plus 1 upon sine t. Continue. A cos square t upon sine t, that's dx by dt. A cos square t upon sine t is the dx by dt value. To find derivative, take this local, take the ratio of this and this, ratio of this to that. Check dy by dx. What is this value? This here is a cos t. So right here, a cos t divided by a cos square t upon sine t we have. That'll go basically up, right? A and a cancels. Can you check? Cos will also cancel. You'll be left with what? If you continue just for a second, please check. You'll have sine t by just cos t left. And that's my answer as tan t. That's the answer as tan t. Please check. That's the final answer. Tan t is the final answer. Anybody has doubt in this? Anybody has doubt in this parametric form differentiation? Any step is a problem, let me know. This is the same question when you differentiate a function, log function with tan inverse, another function, inverse trigonometric function. Derivative of log function with inverse trigonometric function. Come on. Give it a try. Again, assume this as P, this as Q. dq by dx is simple, right? dq by dx is very simple. Tan inverse function derivative we just learned today, 1 upon 1 plus x square, derivative of tan inverse. What about this part over here? This part over here, derivative of log will be 1 upon x square. Is it sufficient? No sir, because that's for log. We're going to differentiate this as well. You'll have the answer as 2x, because 1 is 0, derivative of x square is 2x. I want to find dp by dq, right? That's the ratio. We have 2x upon 1 plus x square upon 1 upon 1 plus x square. Check. This is cancelled. My answer is coming as just 2x, and that's option C. That's option C. Answer coming as just 2x, that's option C. Yes. Have a look. That's option C. Clear? Okay. So we have discussed so far logarithmic differentiation and parametric form. In that we also discussed derivative of a function with respect to another function. This is implicit differentiation. What's the meaning of this? So whenever you are getting a question, there is no direct subject given. Usually, we get the question as y equal to fx. This is called as explicit function. Explicit function. So whenever you have this form, you can differentiate directly. But what if in the question they don't give us this? They do not give us this. Then how would you solve it? Y equal to fx is given. How would you solve it if it is not given? So you have to treat it like an equation itself. For example, simple forms are over here. Okay, we can also have this kind of form as well, where you cannot find directly y in the question given to you. So we're going to differentiate both sides of the equation as it is. Whenever you have to differentiate a term with y, do not forget to multiply with dy by dx. That is basically your chain rule. Okay, collect all the derivatives on one side and basically solve the equation for that. Okay, solve the equation for that. That's the condition for implicit differentiation. Some simple cases. If you have polynomial function of this, differentiate it as ny power n minus 1. Sin y will be cos y dy by dx. Same for e power y log y product rule as well as quotient rule. Okay, you'll have derivative present in all the cases. Dy by dx in all the cases. Okay. What about this question, sir? If you have cos x power y, cos y power x, cos x power y, cos y power x. So if you want to solve this question, how can you solve it? Take log on both sides. You'll have cos log of cos x, and this y will come in front, y log cos x. Over here you'll have egg log x log cos y. Can you see that? Take log on both sides. The coefficient comes as the power comes as coefficient in both the terms. Then you have to differentiate it. Differentiate y log cos x, x log cos y. You're gonna use different, product rule as well as chain rule. Apply the conditions over here. If you differentiate this y, you'll get dy by dx. Then you have log cos x as it is. Can we differentiate it, because we'll need more space from here? Let's go. We'll have dy by dx and log cos x as it is, plus this time y as it is, differentiate log cos x, you'll have 1 by cos x into minus sin x. That's the LHS side. Let's solve the RHS. Over here, if you differentiate x, you're going to get 1. Then you'll have log cos y as it is, plus x as it is, differentiate log cos y, you'll have cos y over here, differentiate cos, you'll get minus sin y, differentiate y, you'll get dy by dx. Dy by dx. Okay, sir. Now, the second step was to write all the dy by dx terms on one side. So we'll move this on this side, this term over this side. This will become dy by dx log cos x, this term, that is negative term comes over here, becomes positive. So plus we have x sin by cos, that's tan y, that is as it is dy by dx. That is also dy by dx over here. This you check, we are getting log of cos y, and this will come on that side, will become plus y tan y, plus y tan y. This is a negative value, becomes positive, y is there, and sin by cos is, sorry, no, it's not y, that's x actually. That's x actually. Did I miss the variables anywhere? No, all good. Take dy by dx common, guys, here. Take it common, you're gonna get x tan y plus log cos x. LHS side, over here you'll have same thing, y tan x plus log cos y. Just simply put this in the fractional form, you get the answer dy by dx equals to y tan x plus log cos y divided by x tan y plus log cos x. That's your answer. That's your answer. Anybody has doubt in this question of implicit form, go ahead and ask me. Anybody feels, say, can you explain this part again? Any part, go ahead and ask. Yes, because not much is there in the implicit function. Usually they club the question with second derivative. If they're asking for 3 marker, for 2 marker, they'll give you simply combination of inverse function of trigonometry or trigonometric function with algebra, something like that they'll give you. Otherwise, there's no much challenge in the implicit function type questions. What about this? What about this? What about this problem? So this is a constant. Can you see that? That is a constant. Tan inverse of a constant A is a constant, right? So can I write this as x square minus y square upon x square plus y square equals to, move cos over there. So cos of tan inverse of A. This is a constant, guys. This value is a constant. And move this term over here, you're going to get k times of x square plus y square. We'll do one thing. Keep the x square terms on one side. We'll get x square minus, move the x square term over here, minus kx square. And on that side, ky square, yes, ky square plus y square, correct? Right? So you'll have kx square, ky square. Check this out. You'll have this as minus kx square on this side and ky square plus y square on that side. Okay. If you check, we have x square common, we'll get 1 minus k, and we have over here y square common, that becomes 1 plus k. Right? So if I solve this in this form, we're going to get 1 minus k upon 1 plus k is equals to y square upon x square. Y square upon x square. Right? Okay. So if I take this as another constant, let's say c, 1 minus k upon 1 plus k is another constant, c only. Take c equals to y square upon x square. So you get the answer as y square equals to c x square. Correct? Differentiate this. You'll have 2y dy by dx equals to c 2x. c 2x. Check. 2 and 2 cancels. And the value of dy by dx is nothing but c times of x by y. If you move the y on this side, 2 is cancelled, dy by dx is c times of x times of y. Just last step, guys. C value is what? This. C value is this. So you'll have this as y square upon x square times of x by y. Check. X will cancel x square with x. This will cancel with y. What is the answer going to be? Y by x. That's my answer. So two beautiful questions in terms of parametric form. This was with cos, means trigonometric function. This is simply, algebraic function. Clear? Anyone has doubt in any of the steps? I hope all of you know where to download the PDF from, the class lectures, how to watch it again. All is available in the AIO page. Okay? There's no charge for that. It's completely free. Use it properly. Very important concept in this chapter I'm covering today, because all of them are very likely to come in your exams, both boards and KCET. This is the last concept for the day. Second derivative. Basically, this comes from which concept? Successive derivative. Means when you differentiate the first derivative, you get second. Differentiate second derivative, you get third, and so on. Basically, differentiate the derivative, the first derivative. This becomes what? Second derivative. Sometimes write this as f double dash of x, or this what I wrote right now, or y2, sometimes y double dash. That's it. If you take example to understand this, if I write x as, if x is my displacement function, think about it. Or let's say y is the displacement function. Then what happens to dy by dx? This will be your velocity function. Correct? If y is my displacement function, then dy by dx will be basically velocity function. Or if I write this as dy by dt, actually, it will be more making more sense. Okay. dy by dt, correct. Then if I write again d square y upon dt square, means differentiate the velocity again. Remember, rate of change of velocity is called as what? Acceleration. That's called as acceleration. Correct? Rate of change of displacement is called as what? Velocity. Rate of change of displacement is called as what? Velocity. Differentiate velocity also one more time. What does it mean? Rate of change of velocity is called as acceleration. And what is derivative? Derivative is nothing but rate of change. What type of rate of change? Instantaneous, at that instance. Okay. So second derivative is basically derivative of the first derivative. Okay. Let's look at a question on that. This problem. Very, very, very good question. Guys, now from here onwards, I have some MCQs I would like to solve for all of you. Let's solve these questions right now. And they are very good problems. Trust me on this. They can be, modified and asked in your examination in your CET. They are very good problems. So please try to make an honest attempt to understand the question. Try to make an honest attempt to understand the question and solve it. Of course, I'll help you. Come on. The topics, Shushan, or basically the whole chapter. Check. If you talk about just the topic, so this is how it looks, right? Yes, 1 second. I wrote that over here. It comes for 17 marks in your boards. This chapter is weighted 17 marks in your boards and 5 marks in your KCET. Okay. And the question that is coming from this particular concept that I'm discussing today, I've discussed today logarithmic differentiation, then implicit function, then parametric form, and then we have second derivative. This will come for 3 marks, usually 3 or 2 marks. Sometimes it comes for 2 marks also. This can come for 2 marks question. This can also come for 2 or 3 marks. This can come for 5 mark question. Okay, where this and this is almost guaranteed. This will come in every single paper. This and this will come in every single paper. Again, out of these 4, at least 2 to 3 can come in your CET as well. Clear? Is this clear? Yeah. 1 second. Yes, guys. For this question over here, let's try to solve this now. Look at the problem. They have given a function inside. Power is given as m. I want to differentiate it, right? Differentiate this. dy by dx. Since they're writing y1, y2, let us write that as well from our side. We'll write derivative number 1 as y1 only. So it will become what? M times of, this is the polynomial function basically, x plus root of x square plus 1 power m minus 1. And what next? By chain rule, this part's derivative x plus x square plus 1, this function's derivative they're asking, If you differentiate the y, you'll have, this is the condition. Differentiation of first will be using polynomial condition, and then the chain rule will come. Continue and check over here. y1. This is as it is. We are having x plus root of x square plus 1 to the power m minus 1. Differentiate that other side. You'll have x as 1. Derivative of the root will be 1 by 2, same root repeats in the denominator. Differentiate the value inside, you'll have 2x. That's it. That 2 and 2 is cancelled. That 2 and 2 is cancelled. Continue. y1 equals to m times of x plus root of x square plus 1. Okay. Check, this can be taken as LCM, right? You have just this left. X square plus 1. If you want, you can take this part as LCM. Just this part. Check. If you just continue for this part over here, you'll have the LCM as x square plus 1. X square plus 1. And this will become x square plus 1 again, because it is 1 plus multiply and plus x. Clear? Just this part I explained over here. This part is explained over here. Continue. So I'm getting y1 equals to m times of x plus root of x square plus 1 power m minus 1. Check carefully. I'm getting the same value over here also. X plus root of x square plus 1. Okay. Okay. Divided by x square plus 1. From here, if you multiply these two, it'll become m minus 1 plus 1, because this power is 1. If you do that, you have to add the powers. So you're going to have this value to the power m. You'll have this value to the power m, and that is what? Y back. You get the y back. Okay. So you're going to have the value as y1 equals to m times of, check here, y upon this value, root of x square plus 1. Is this clear? Is this clear? This into this becomes y back. So you're getting what? y1 equals to my upon root of x square plus 1 cross multiply. You'll get root of x square plus 1 times of y1 equals to my square both sides, square on both sides to get rid of the root, because you look at the option, you don't have any root available, right? So get rid of the root, square on both sides. You'll have here x square plus 1. This will be y1 square, m square, y square. Now differentiate it, because what are they asking in the question? X square plus 1 times of y2. So just keep this as it is. Differentiate y1 square. You'll get 2y1. Derivative of y1 square is 2y1, and differentiate y1 again. Differentiate y1 again. Okay. That'll become y2 actually. We'll do that later. And this is product rule. So you're going to have this differentiation next. Derivative of this is 2x, y1 square. Over here, m square, 2y. Again, derivative of y is y1. Derivative of y is y1. Check. This 2 y1, 2 y1, and 2 y1 is cancelled. 2 y1, 2 another y1 from here, and this is also cancelled. What I'm getting now? X square plus 1. This is derivative of y1. It becomes y2 over here, x y1 over here, m square y. Move on this side, your answer becomes what? M square y minus x y1. M square y minus x y1. Option is D. Option is D. Have a look, guys. Clear? Please try this question one more time. Whatever question I'm solving in the class, try to solve it at least one more time after downloading the notes from the AIO page. Okay? On the learning platform that you have, download the notes and solve these questions again. Very important. Over here, this problem. Y equal to what we have? Check this out. Log of log x with the base x, with the base x. We're going to use the property of log over here, base change formula. So write this as log of log x upon log x. Both with the base e only. Both with the base e itself. For this part, log of log x with the base e. This is log of x with the base e. Okay? Right? I want to differentiate it. You can use quotient rule over here. So write dy by dx. Differentiate this part. What are you going to have? Differentiate this part. You're going to have the derivative of this will be 1 by, differentiate the first log. So 1 by log x will come. Differentiate this part. You're going to get 1 by log x. Now differentiate this log as well. You'll have 1 by x. This is just for this part. Into log of x. This is as it is. Denominator. Minus. This is as it is. So log of log x with the base e. Differentiate this log. You're going to get 1 by x divided by log x with the base e whole square. Right? This is the answer. Check. This is getting cancelled, sir. This is getting cancelled. And also, you can see x is 1 by x and 1 by x is common. So you're getting this value. If you want, you can just start putting the value x as e also. You'll get the answer. You'll get the answer. Put here 1 by e minus log of log e with the base e into 1 by e upon 1, because log of 1 e is what? 1 square. Correct? Yes. So getting the value as over here 1 by e minus, check this out, this becomes log of log e is what? This is equals to 1. So we'll have over here as 1 into 1 by e as it is. Continue. This is also 1. I get 1 by e minus log 1 is what? 0 into 1 by e. That is going to be cancelled. You will have this all 0. Answer will be 1 by e. This will be the answer. This will be 0. So answer is option A. Answer is option A. Okay. Next. Y equal to tan inverse of root of 1 plus x square minus x. This question is on substitution again. Take here x value. Take here x value as what? So you can take either tan or cot. Either tan or cot. Okay. All right. What can we take over here, sir? If I take tan, okay, let's try to take cot. Okay, let's try to take cot. So you're gonna get what? 1 plus cot square of x. That'll become what? Cosec x. This expression becomes what? Y equal to tan inverse of, this value is cosec. Cosec x minus x is what? Cot. So cot x. That's my answer. First step, basically. After this, simplify. Tan inverse 1 by sine minus cos x by sine. Check over here. Tan inverse of sin x is the LCM, 1 minus cos x. This is the result I asked you all to remember. Please remember, If you're watching for the first time, please remember this result always very, very useful. This numerator is what? 2 sine square x by 2. This is what? 2 sine x by 2 into cos x by 2. We're using half angle formula for sin x and half angle formula for cos x. Check. 2 and 2 cancels. This sign will also cancel. You'll have the answer as tan x by 2. It becomes tan inverse of tan. Okay, there's a mistake I've made. The mistake is that I've taken it as x as cot x. So it'll be always what? Theta actually. Let me change that. 1 second, guys. This will be theta actually. Sorry. This will be theta. My bad. This will be theta. Theta actually. 1 second. Yeah. This will be, yeah, theta over here in the question that I've taken. Okay, clear now? All right. So this becomes what equal to theta by 2 is there actually. It becomes theta by 2. If x is cot theta means theta is cot inverse. So I'm getting this value as half of cot inverse of x. This is the value for y. Differentiate this, you're going to have minus 1 upon 1 plus x square with 2. So answer is coming as option C. Answer is coming as option C. Mantesh, please check. Answer should be C, bacha. Check. Is it clear? Next. Function fx is equals to mod of x minus 3 upon x square by 4 minus 3x by 2 plus 13 by 4. Two branches are there. But our clue is continuous at 1 and continuous at 3. We know one thing very sure. At 3, this will be what? A modulus function, right? So after 1, right? After 1, if this is the point 1, the graph is something like this. So somewhere around 3, this is going to be a straight line. It's going to be a straight line. So always continuous. That is always continuous. Yes or no? Yes, sir. This is always continuous. It means option C is for sure true. Let's look at option A. If option A is also true, it means my answer is option D. If option A is false, it means my answer will be only option C. Correct? Because this function is going to be a straight line after point 1. After x equals to 1, this is a straight line. Always continuous. So C is true. Option C is true. It all depends upon the option A. If option A is true, then answer is option D, which is all of these. If option A is wrong, then I have to check the answer as only option C. Okay, let's look at the option A. So continuity I'm looking for. Let's find RHL, which is the same in this case as f of 1. You can check because the branching is from here. You're gonna get the answer as 1 minus 3. How much is that? 2. Let's find LHL also. Let's find LHL. For that you have to put in this value. So you're gonna get 1 by 4 minus 3 by 2 and 13 by 4. I'm putting in this branch for LHL at 1. I'm finding this at this. Put the value back. Okay. LCM is going to be 4. 1 minus 6 plus 13. 1 minus 6 plus 13. How much is that? 14 minus 2 to the 4. Yeah. So, oh sorry, this is going to be 4. Right? Is it right? 4. Yeah. That's going to be 1. And I'm putting the value as 1. Okay, so that's going to be 3 again. So 3 by 2. That becomes 2 to the 4, 6 only. So we have 14 minus 6. That's going to be 8 by 4. It's 2 only, right? Can you see they are both equal? It means what? I'm getting basically at this point my RHL equal to LHL equals to f of 1. Therefore, continuous at the point x equals to 1. So this also is true. It means my answer is option D. Answer is option D. Have a look. Is this clear? Next. This problem again, if you go with finding this algebraically, it'll take time. But if you draw the graphs, look at this. The branchings are -1 and 1. Before -1, the value is this -2. This is -2. This is +2. This is the graph. After 1, the value is this. And in between, the value is a line like this, 2x. Okay? Y equal to 2x. This is the curve. Y equal to 2, y equal to 2x, and y equal to -2. Now look at this. Does this graph look like ever discontinuous? No. So my answer is what? Continuous for the entire real number. Continuous for entire real number. Next. Great to hear that, dost. Okay. Find derivative if you have the conditions given over here. U is given as 1 upon x power 2 by 3. This becomes what? X power minus 2 by 3. If it is given in the reciprocal form, I can take with the minus sign in the index, in the power. So this is clear, sir. U is x power minus 2 by 3. Now we'll use this in place of over here in the function y. 2 times of x power minus 2 by 3, the cube plus 1. This power 3 cube plus 1. Condition 2 times of x power, what is this? Minus 2 plus 1. And to find the derivative, right? So find the derivative. We'll have 2 times of minus 2 x power minus 2 minus 1 plus 0. It becomes minus 4 x power minus 3. That's nothing but minus 4. This comes down x cube. Minus 4 upon x cube. Minus 4 upon x cube. Clear? Any doubt in this? Not really, right? Very simple problem. Simple question on the polynomial. Now over here. So this question is combination of 2 logarithmic function will take too much time. This is the KCET P/Q, by the way. This is the KCET P/Q. Then how would you solve it? How would you solve it faster? So which is looking simpler to you? This part or this part? For me, the second part looks simpler. So I'll take x power log x and differentiate it. Let me take this as, something like p. And I'll take log p equals to what? Actually, if you remember the formula, it'll be much faster. There's a formula actually. The formula is dp by dx is given by x power log x. If I take this as, let's say, f and this as g, then we'll have f power g times of f dash by f plus g dash log of f. G times of f dash by f plus g dash log of f. Apply. Your g value is log x. So you're going to have this as x power log x as it is, g. So log x as it is, f dash will be 1. And f is what? So log x by x I'm getting over here. Now g dash, this value g dash, check here, g dash becomes derivative of log. So 1 by x, and log f will be log x. Isn't the same thing? Log x by x, log x by x. I'm getting the value as x power log x into 2 log x by x. Look, which option is there? So either this option, sir, or this option, sir. This is not there because we have a plus sign over here. In the question they've given us minus sign. This is wrong. So either option A or option D. You can look at this. Derivative of this can never be just this part. So you're saying derivative of this part can never be log of log x. Okay. So clearly my answer is what? Option A. Because this is the same y multiplied. Okay. This was same y. But you differentiate log x power x, no? You'll have derivative like this. In this form. So my answer is option A. So you can use option to get the answer faster. Yes, makes sense. So answer is option A. All right. Anyone has doubt in the previous question? Go ahead and ask me. This. How do you solve this question again? Sir, this is x squared plus root of x squared plus x squared plus till infinite number of terms. So if I remove all of this, basically I remove x square from here. What is this value? That value is same y. If you look at this, this is same as y. From infinity you remove something. It is still same as infinity only. So y. Take whole square. You're going to get y square equals to x square plus y. Move on this side. Y square minus y equal to x square. Differentiate this. Differentiate that. You're going to get the answer. Or there's a formula. If you're having y equal to root of f plus root of f plus root of f till infinite number of terms. Derivative is simple. Derivative of f upon 2y minus 1. Look at this. Here f is what? Here f is x square. 2x upon 2y minus 1. Answer is option A. Answer is option A. Please check, guys. Answer is option A. Yeah. So this was it in this class. This was it in the class where I talked about different forms of differentiation, solved question on each category alongside some important questions relevant to KCET. Non-KCET PYQ. These are not KCET PYQ, but relevant to KCET. If you think something is missed, let me know in the comment section. Let me know live chat. If not, this was the class. You should, if you want to rewatch it, you can rewatch it on YouTube as well. You can rewatch it in our all-in-one learning platform. Okay, where you can get notes, assignments, doubt solving, everything is available, and this is again of no charge. Okay, how do you access it? Simply, this is the website. You can click on this link over here given as free second PUC course. Click on that link you click on, you'll get this particular batch over here. If you click on the link, right, let's show you. You'll get this platform. Okay, this is that platform, KCET 2027 prime course. Click on buy. You will find this as coming for 0 rupees. Click on that, get the access to the course. This is my login. Okay, I can show you again. This is how it will come as the batch, KCET 2027 batch. This is for both 11th and 12th student both. Click on this, any lecture, all the lectures are updated over here. You can get, let's say I want to understand, or I want to see high weighted chapters for KCET. I want to click on that notes. So this is I think yeah, all right. That is not updated. I'll update it. Look at this. This note is available over here. We can cross check. All right. Clear? This is good. Okay, guys. So same is available over here. Again, this class note also will be updated over there. Download from there. That's all in this class. Anything else you need from me, do let me know in the comment section. I had fun teaching you all. We'll meet you again in the next class. Till then, take care. Bye-bye. All the best.